to be Unit 7, looking at 4 out of 5 standards of complex numbers. So today a Wednesday. That's where it comes. So I'm reading through these. First, complex numbers. Yeah, I knew that. It's out of order. Right, so we'll do that second sheet because it explains. Let's back this up for just a second. Mathematics, you're thinking of an addition problem. An addition problem where the addition sign, it's linking two pieces together. A real part and an imaginary part. It says here a complex number is a complex number is a number that can be written in the form a plus bi. The I part is important. The A and the B are any other numbers, like A could be a 74, an A could be a 13, a B could be a 13. It doesn't matter those numbers. The I stay the same, where A and B are real numbers, and I is this thing here. I is this problem that's broken. Hey, what's the square root of -1? We don't know. But if we say there really is an answer, though, we don't know what it is, then it fixes a lot of other problems that need, well, you need the answer to this to be able to do the rest of the stuff. Like, we don't know what it is. Like, all right, just give us something, like, say the answer's in this bag, and then take the bag with you. As long as you give me, like, a suitcase, like in a mob movie, like, give me a suitcase, like, there's money in it, they'll make the deal, we'll make the bus. Well, I is the brown bag. We don't know what's in there, we don't know what it means, but we do know that whenever they say something like, hey, it's an imaginary number, you say, oh, you mean I? And they're like, yeah, how'd you know? Regardless of what it means. Here, the set of real numbers is a subset of the set of complex numbers. What does that mean? The set of real numbers is a subset. When we say all real numbers, we mean the same number, 0. We mean decimals, like negative 1.2, negative 3.4. Those are called all real numbers. Well, complex numbers, like, look, not only do we take the real stuff, but we do even more than that. And therefore, what you see here in this picture is that what we call the real numbers are part of this complex set of numbers. The world of complex includes the real and the imaginary. Anytime you see a negative sign inside of a radical, like here was for -7, you just say, oh yeah, it's an imaginary number. All right. Every complex number, this part's going to be important because when you write your final answer for this first section, there needs to be something out front and something behind that has an I with it. No I, you haven't written a complex number. And there will be 3 questions on that test that will have you do that. I can't see which standard it is, but I know you'll have to do it on one of them. I'll have to find it. All right, so let's see. We got the real and imaginary part. You would, I don't know if this happens, you know, I've never been, but I've seen movies. But apparently, there's this concept of conjugates and conjugal visits. I don't know where it happened. I don't know how much gets it. I don't know how. I don't know. But the point is, usually, it's just way too good. Well, the signs are opposite. Can you see that? So on a conjugal visit, conjugates, opposites. Hard to go with it. Yeah, then let me go any further. Hey, the solutions. This was a problem, and they did what you're about to do on the back of this page. Once they did all their work, one of the answers they got was a -5 plus I10. They also got the second answer using the quadratic formula, -5 minus I radical 10. And they said they're related. These solutions are a complex conjugate pair. Please highlight complex conjugate pair. When you hear that phrase, something should pop up in your head. Let me ask. Complex has to have an I, conjugate has to have 2 of them. The positive version of it and the negative version of it. Now it's that middle piece, the middle sign that switches. Notice the 5 is negative on both of them, so it's the middle piece that switches. And obviously a pair. The complex conjugate of any complex number a plus bi is the complex number a minus. This is math talk for, hey, what's the conjugate of a plus bi? Oh, a minus. Go ahead and circle those, the plus and the minus, and that's your key to the whole conjugate thing. The quadratic equation with real coefficients has non-real roots. Those roots are complex conjugates. We're going to read that again. Math talk. If a quadratic equation, which they're about to solve right now, with real coefficients has non-real roots, those roots are complex conjugates. In English, if there's a picture of a polynomial function, those wavy lines, and they are floating above the x-axis, they are imaginary roots. In other words, the letter I is in there somewhere. See if there's a picture I can show you of that. When given one complex root, you can always find the other by finding its conjugate. Got it. If you give me blue, I can automatically get red by switching the sign on blue. All right, so what is that? It's their job to do. Their job is to do the quadratic. Hey, Thomas, in this problem, you can give me a quadratic equation. Does anybody know what makes this quadratic? Teachers use that phrase all the time. Hey, there's a quadratic function, there's a quadratic formula. Quadratic. It makes sense. They should have said something about 2. It turns out it's this little 2 up here. This is the second to the last one, according to this little thing, and I want you to put a mark on it. You will hear this word quadratic so often. Quadratic. I want you to have some pop into your head when you hear quadratic. Technically, for an equation, you need to see the letter, a variable, raised to a second power. The other thing that you should think of is it's going to be a parabola. In other words, you'll see a picture like that. The red part is also when you hear quadratic. I don't need you to know how to get it. Just, hey, when you hear quadratic, it's a quadratic function, quadratic formula. Well, yeah, it has something to do with this little 2 or that hyperface. So let's remind them, step 1, to use a quadratic formula, 1, you need to know it. So I'll say it, remind some who've heard it before. It goes like this. There's a bad boy. Probably wore leather. This bad boy. He wasn't quite sure, he wasn't positive or negative as to whether or not he would go to this house party. He decided to go, but it turns out, as compared to the people at the party, he was a square. The boy was a square. Square 50 terms for for those guys, greasers or happy days for not being cool. He was a square, so he missed out on 4 awesome chicks. Chicks, ladies, in England, women are called birds. America, I guess, a baby bird, a cute bird is a chick. In any case, the party was all over at 2 a.m. I had the unfortunate, hey, any formula, it could be algebra 2, it could be pre-calculus, it could be calculus. They're all the same. They have letters. You get those letters from somewhere. You plug it in, work it out. 3 people, 3 tables. You guys get up. Tell me what letter A is going to be, what letter B is going to be, what letter C is going to be. If you remember, if you don't, I'll tell you. Get ready. All right, what you got for A? David, if you know. Q is correct. The square term, the leading term, it's a coefficient. Coefficient, boom. Please mark coefficient number in front of a. All right, here it comes. So A is the coefficient of the square term. Hey, B, what do you guys at the table? Either Tina or Marcos for B? 20. 20 is correct. I'm going to include the entire minus sign when it's time to pluck it off. Yeah, you wind up with the whole negative 20. And then Oswaldo, what do you think C is? 53. Yeah, 53. In this case, just a positive 53. Those are the A's, the B's, and the C's. Usually a teacher asks for it to be written somewhere. You'll notice theirs. And if you have a highlighter, since we're looking at a completed product, you can highlight there. I wonder if did anyone notice those X's there at the time or no? Or they were on the side. All right, so here's what they do. When you put it in, and you're about to do this right now, I'm going to recommend that you, for any letter that you're going to put something in, put minus and then put a parenthesis for what you're going to put in the place of the B. The reason I like that is some students, for the 20, since it's a negative 20, they know it's a minus B, They just put, oh, just negative 20. Like, they don't put in an extra minus sign because they figure, well, the minus sign is already there. That's the minus sign in front of the B, but it's not. B is read also as the opposite of B. Oh, B is a 20. The opposite of B, opposite of a negative 20, happens to be a positive 20. So in math, you can read a minus sign as the opposite of. In any case, there it goes. What is he doing right now? He's putting parentheses wherever letter is going to be included. I don't know what your space is. I don't know where you're writing, if you're writing, but I still want to make the point that when you use the quadratic formula, write it out first with the parentheses and then start plugging stuff in. Take a moment, look and see what they have written there. The most important part, you can put a star here, you can highlight here, is this line right here. You put that line in there and you mess up somewhere, I can at least go, like, I can give them some credit because they got stuff in, they just didn't know how to do X, Y, Z. But you missed this part here, then of course the rest can't work out for you. The other place that's super important in this is, yeah, we put it in. Hopefully the next line you see the negative 20 is the opposite, positive 20. Negative 20 squared, negative 20 times negative 20 is 400. No big deal, that's not a big deal. The minus 4, the 2, and the 53, what I usually tell students to do is do the positive stuff first. In other words, do 2 times 53. You'll have a calculator. Matter of fact, let me pass those out just in case your problem becomes really big. 72 back, please. And then, after you multiply the 2 and the 53, then multiply that answer times that minus 4 times the negative 4. When you multiply under this roof, some people will just multiply the 4 times whatever and then remove the negative sign. You need to know that that's a negative 4 being multiplied when it's time. In any case, they do all their multiplying there. You wind up with the 424. If you have a highlighter, I want you to highlight this negative 24. That's another super important part for this section. The minute the number that's left under the radical is a negative, automatically, hopefully, say I was getting an answer here. At this point, I could put an I and a 24. This I, which I should have written in a different color because that's the thing I actually want you to pay attention to. If I do it in blue and you have 3D glasses like this coming right at you. That I is the difference between, I need to get this negative sign out of here. How do I do that? We just take that out and we call it I. It's just a rule and so on. All right, let me read what they have here. I won't go down any further than, do I want to say what they did here? I'm gonna go from here to here the way I do it, and then let you hear, and then try yours and see if it does all of that. Hey, now we have an expression with a negative under the radical. Until now, students would have claimed this equation has no solution. In fact, it has no real solution. Highlight no real solution, please. But it does have a complex solution. Highlight complex solution and put the letter I below it. I want you to hear whenever you hear complex now, just know that means it has 2 parts, the A and the B, and that letter I, the letter I. Here you go. Hey, we define this. Highlight it one more time. Sure, why not highlight that I is equal to radical, the square root of negative 1, is an imaginary number. I struggle with that idea. Imaginary, it's not real, then all right, whatever. When we can combine an imaginary number with a real number, we call it complex. Go ahead and highlight complex number. Well, actually highlight that whole sentence. That's the official definition. So if anyone has complex number, that's the official definition, combining those two. Complex numbers are written in the form a plus bi, they know that. Using I, we can simplify the answer above. So what part is it that I want to do for them? Hey Thomas, how do you go from this negative 24 thing to where it's a 2i? One, we know the negative sign produces the I. No problem there. Where are they getting this 2 and 6? Let me find out who remembers what. Anybody remember how to get the square root of a non-perfect square? Like, it's not a 25, it's not a 36. That'll do. Thank you. I'll do that. All right, here it comes. The rule is simply this. we have what are called perfect squares: 4, 9, 16, 25. That's as high as you need to know. If you don't know any higher than that, you're A-OK. The rule simply says this. If you get a non-perfect square, to break it down, you need to pick one of the numbers off this list and divide it into this one. The biggest one on this list that can go into the 24, you divide it into that, it'll break it into two pieces. So in this case here, 4 is the biggest number that goes evenly into 24. He goes first. Anyone know how many times 4 goes into 24? Yeah, 6 times. So I just wrote 24 in factored form. Let's see, factored form. Anytime you multiply, there it is, ooh, factor. Write the word multiply and factor if you have out your vocab. There's another way that we're going to put down factor. Anytime you write one thing as a multiplication of 2 or more other things, it's called factored form. So here we go. I'm going to put the square root above both these guys again. Anybody know what the square root of 4 is? Yeah, there's a 2. Anybody know the square root of 6? Right, you shouldn't. And as a result, the 6 remains in the house, and the 2 comes out. Whenever you have a square root of a non-perfect square, you always break it into two pieces. Piece that's perfect, these are called perfect squares, and the other guy. The perfect guy gets to come out of jail, just like today. 160-something people were commuted out of, 100-something people were in jail for drugs or whatever. Non-violent, perfect, you stay in. From this point on, I'll just say what they did next. For whatever reason, they decided to factor out a 2, which you won't have to do. I think at this stage, the way I would explain to you how to do it, if I were at stage here, the rule that we generally use is 20 plus or minus the 2i radical 6 over 4. You look at these 3 pieces, 1, 2, 3. You say to yourself, is there one number that goes in all 3 of these? Well, it's even. 2 does. So what you'd wind up doing is you divide the top by 2, and you divide the bottom by 2. And what you should get is that 2 goes into 20 10 times. 2 goes into 2 1 time. You don't write a 1 in front of a letter. Really sorry. The radical 6 is still there. Nothing happened to it. And then lastly, the 2, the 4 on the bottom turns into a 2. Take a look at this answer here and see if you want to ask about any of the numbers. Like, whoa, would you get? Take a brief look there. All negative, really? Don't they know students don't generally like negative numbers? Alright, I'm sure I'll do plus minus squared minus 4. Oops. All over 2. Alright, so minus 3 goes for you. You're 1. And your first one. Oh, yeah, thank you. Erase the whole thing. Alright, and you come again a negative 1b. Right. What's the negative 3? And a negative 10. Down below a negative 3. Again, that's the most important part. You need to fix something, change something on that. You can. Place where people mess up, maybe they won't make it. Well, no negative 3 will make that. I don't know what they'll put there. Maybe they'll just put a regular 10. Alright, let's see if we can keep going with this thing. Next line down. You're a regular 1. Anybody know what negative 1 squared is? Yeah, just a regular old 1. Let's see here. Negative 3 times a negative 10. The 2 red guys make a positive 30. And that positive 30 times this negative 4 should give us a minus 120 or a negative 120. All over the bottom is a negative 6. Pause.
Negative 6.
All right, let's see. I say negative 6 on the bottom, and you're saying something over here. Okay. Take a look and see if yours matches mine. And if mine is wrong and you happen to be able to help me, I'm for that. The radical, also known, what's inside of it is called the discriminant. Yeah. The discriminant over here, number under the radical, you can do the quadratic formula and write, it's not what's there, it's the discriminant is inside. And is that an I in there? This, not at the end, discriminant. At the end. Nonetheless, the discriminant is going to wind up being negative. Anybody know what 1 minus 120 is? So negative 119. Now here's the trick. I don't think 119 is going to break down to anything. I think we'll try a few calculator things. No, I'm trying. So here's what we'll go on the next line. The next line is the most important. I don't have any space. I think this problem is going to stop with a 1 plus or minus I radical 119. Can I write on you? I can. All over 6, that's a negative. Let's pause and have you for that one is going to be, okay, let you write down. It's 3 parentheses. What's in the first one?
A plus 4 plus 5.
5. Second one?
Negative 1. Negative 7.
Negative 7. All right. Solution. Degree solution. Now this problem is pretty important. Degree, orientation, solutions, how many there are, the zeros, yeah, this part becomes really important. Zeros, x-intercepts, solutions. I'm going to put all 3 words. It's a bad idea. X-int, I'll put that in parentheses. That's what it means. Solutions, what they actually are. I'll put that in parentheses so that if they use more than 1 word, you know the other ones. Y-intercept. And then I'm going to put this thing called end behavior. After this, we'll start looking at some pictures and see if we can do the thing, and eventually we'll graph it. I'll remind you all the stuff we know about graphing. So in a way, this is kind of a series they remember that tell them. Then we'll do a bunch of them kind of over and over. And I think the level of this one is about the level that they might put on a test. One other thing I want you to write down, I wish you could put factored form. Anybody know what word to think of when you hear the word factor? Five raised to the 1 power, so that you don't have to do anything to it, times this negative 1 raised to the 2 power, and then lastly that negative 7 raised to the 1 power. So when you get the y-intercept, just take whatever numbers are in the pods, multiply them together. Now if an exponent says, well, do something before you multiply it, okay, do it before you multiply it. That is, negative 1 squared is just a 1. And now in this case, you wind up with those 3 numbers. Pause, take a look at that. What you should know, this is typical math in the sense that It's not especially hard, each of the steps. It's just that you got 20 steps. You have to remember them. Not only do you have to remember the steps, you got to remember their names that are supposed to tell you. And now I'm going to try and graph this thing. To graph it, these guys here are the most important guys that you need. So I'm going to put in some numbers on here. Let's see if I can do it. 1, 2, 3, 4, 5, 6. What do I need? A 7? Sure, I need a 7. Backside, just need a 5. 1, 2, 3, 4, 5, 6, 7. Going up. I don't know. 1, 2, 3, 4. It won't matter. 1, 2, 3, 4. That negative 35, I'm going to have to place it in anywhere. Alright, you are my X. You are my Y. And we'll go backwards on a few of these. Again, I felt like earlier I may have asked you to build something for those who aren't here. How do you build the different degrees? This degree is a 4. You start building from 1. That's degree 1. That's the arrow shooting up from bottom to top. Anybody can do an arrow shoot from bottom to top. Even if you're not good at math. Yeah, I suck at math. Okay, yeah, you can do an arrow. To do a degree 2, and again, it's supposed to be smoother, but for the purpose of this, I need a 4. You just keep building to your left. Start one on your right, there's a 3, and there's a 4. If you forget what a 4 is, a 4 looks like a W. It has 4 of the little lines. If I needed a 5, I keep going left, right. Not hard, just you got to remember it all. This shouldn't be under end behavior, though. Though it kind of is. And I'll explain that in a second. Here we go. Hey, draw a picture, Thomas. Where are my dots? I got a negative 5. I just put negative 5 here. 1, 2, 3, 4, 5. There's my negative 5. I got a 1. If your picture comes off, look, no, they're important, but if anybody has this much and mess up on the picture, I want to give you something. A 7, why are you 7? All the way at the end. There's my 7, there's my 1. Because it is a W, and because the orientation is positive. If it were negative, that W would flip down and wind up looking like the letter M. But because it's positive, it's just the way it normally is. So I come in from the sky on this one. Let's see, coming from the sky, and I got to hit. The first thing I'm doing is I'm going to hit that 5. 5 is a single, so I go straight through the 5. When do I start turning? Well, it doesn't kind of matter. Oh, in this case, it does matter. When I start turning that corner to get to that 1, because that 1 is on the other side of that Y line, you must go through the Y-intercept to get to the other side of the Y line. That is required. The Y-intercept is a negative 35. But I only have 4 here. Okay, I'm going to put negative 35 here. Does it really go there? No, it doesn't really go there. But when you cross the line, normally the Y-intercept is either too big for your picture or too low. So you just put it so I can see it. So I'm going to put a dot here for you, negative 35. And now I'm going through it. If I were doing that, I would slant a little bit more, but whatever. See if they are okay with that. Now start climbing up the hill to get to that 1. What's going to happen at 1? 1 is a double. Anybody know what's going to happen on a double? Good. We got 2 bounce off. When I come back down, the question, well, how low do I need to go? It doesn't matter. At some point, you got to turn the corner to go through that 7. Turn that corner to go through the 7, and it goes up and up. I put arrows at the end of these things. Some other math teacher, she's just mad at me, like, dude, it can't be flat. All right, I know. I just came in the wrong angle, but yeah. So, all right, take that as x approaches negative infinity, y approaches positive infinity. Same thing they got to say on this side. Well, what happens when you go this way on the x line, like towards infinity? Well, what is the arrow going to be doing when you do that? Well, same thing. As x goes towards positive infinity, the y keeps going up and up forever and ever. Y approaches positive infinity. And most of the time, this will be true. When you go this direction, it's going to be going up forever. When you go that way, it's going to be going up forever. If one of these arrows was going down, you say, well, as x goes this direction towards negative infinity, oh, then the arrow, the y would be going down towards negative infinity. So let's see if there'll be more chance. On this guy here, see how it says even power? For the even power, put in like sure, x2, x4, x6. Write that down, write that down. Even though I really should have put it up here. For the odd power, of course, x3, x5, x7. I can't imagine that you would get to an x7. And then they have those little rules. Basically, for all the evens, as x goes to negative infinity, it's always going to go up. Y is going to go to positive infinity. And then they do just the opposite. As x, if they have a negative orientation, as x goes down. Those are the ones I'm trying to get to. What I'm trying to get to is these little pictures here that look a little different than the kind that we have. Let me look at one that looks the same as what we have. Now, are these three in order? They want us to match them. These will match together. The other side you're going to try and match on your own. Here it comes. First, for 3, even though I don't know that 3 goes to 3, what is the, what's the word I'm looking for? What is the degree on 3?
Negative.
That's the orientation, but the degree is going to actually be a number. All right. 5, 4. We need someone to break the tie.
5.
Okay. I'm going to break the tie with a 4. That 2 is making us think like, wait a second, doesn't he have an exponent on him? It's letters that have access to exponents. So while you would think, okay, yeah, it should be a 5 because that 2 out front, which is why we're doing this one together, this guy will actually be a 4. And again, he's a 4 because if there was a 2x out front, then it's true that x has a 1 on it.
I was right.
Did you say 4? Yeah, good luck. Way to go on that. Take a look at the second one. We haven't talked about this one. Well, let's talk about the first one because he's a friend of the second one. Can anyone guess what the degree is on number 7, or 1 rather? 5 is a good answer, and I know where it's coming from. If it was in factored form, I'd be like, yes. Say it again. 0. No, I can't go with the 0. This one's going to be way easier than you even think. Like, what? I'll say it this way. In standard form, which is what this is, factored form, standard form, it is the highest exponent in the problem. Yeah. So this one, the factor or the degree is a 3. When there are no parentheses to separate them, boom, you just find the x that has the highest exponent. Booyah, you win. You have a degree. The middle one, someone said out loud, what's the degree on 2?
3.
Yeah. Not only is it 3 here, some people think that negative 2 does anything. No. It's just whatever the guy is. Now the question is, why is that going to be important? Remember, if we build a 3, it looks like this. You start with a 1. Here's a 2. There's a 3. When you're matching the pictures, if you know the degree, you already are able to kind of have a sketch in your head of what you're looking for. And of course, 4, you always start building like that. 2, 3, 4. Do me a favor, match up the pictures, please, with the letters, if you haven't done so already. All right. It makes the picture go, so it would normally end up here. It's not going to do this, it's going to flip to the opposite. So if I can do the opposite, I will. I'm going to set you going down, you go up, down. Notice he started, this is the normal way it starts, low to high. If there's a negative sign or a negative orientation, it starts from high to low. Look at that and see how it feels. You're going to have to identify it on the other side. This negative sign, he starts high to low. The regular guy here, low to high. And this W guy, again, notice on yours, it's a 4. And because of that minus sign on here, we know a 4 normally does that. But if that negative sign goes in front, What was normally high to high winds up needing to be low to low. Pause, take. Anybody who's like, okay, I know one, but I'm not sure about a lot of them. Can I go first? And you want to make a connection. Anybody want to make a connection first? Where you have the most possibilities, or maybe you might want to wait till some get crossed off.
I don't know for sure. But
Oh, I'm sorry, let's do this. I'm sorry, let's do this. I'm going to go around the room, the degrees on the degrees. So once you say 1 degree, then wait for somebody else to say another. The degree on 1?
1.
All right. Someone else agree on 2?
3.
Okay. They agree on the third one? 3. Oh, after you're done one, so the others can get a chance. So right now, I heard, so Marcos, you're coming up next. So that was for, and after that, then we can just do any of them. The degree on the fourth one, Marcos, what do you think?
Which is number 5, right? Or,
This guy right here.
oh,
Or if you want to do 5, you can.
3 on 4.
4. No, that's going to be close. Someone help him out now?
4.
It's going to be 4. Anybody on 5?
2.
Anybody on 6?
4.
4.
Yeah, the ones that are in standard form, you just pick the highest. All right, so we got how many 3s? We got 2 3s, 2 4s, a 2 and a 1. All right, here it comes. If you're confident, maybe wait for some ones that are left over, or if you're confident, maybe go early, and the people who are not confident, you can see what's left over. Here we go. Somebody make a connection. No, number 1 is, or number 2 is, or someone do a connection. And I'll put the number below here. Any connections out there? Do you feel like, oh, I think it's this one?
Well, 1 is F.
1 F. Yeah. That'll do. So 1 is off the list. Anybody else want
2
to?
is A.
Number 2 is A. This is a D3. It's a positive orientation. It does it at 1, at 3, and at 5. At 1, at 3, 1, 3, 5. Okay, 1, 3, 5. Yeah. If you have yours, push, jot whatever I have that might help future. Anybody want to throw another one out there?
Number 4 is E.
4. I hear E. C. That's a good thought. The only reason, well, can anyone say why I would have to disagree with 4 being E? Yeah. That negative sign means that it's going to be pointing down.
So it's C.
Yeah. And so once you know kind of what you're looking for, even if it throws off someone different, 5 where has everyone already answered?
5D.
5D is in dog. This one is a 2. He's the only 2, which is a parabola. If you remember that from 2A. And just got to be done one of these. I feel like.
Yeah.
Okay. Anybody else then can throw in B and E or B or E in there.
6 is E.
6 is E. And again, the beauty of 6, it's a 4. Your only last 2 choices are a 3. See, no, it's a 3. Yeah, no. And then a 4. It's either W, an S, an I, or whatever. So you said 6. And then what's the missing letter?
3.
3. So take a look at it. They are going to have you build one on the test. So the more you come used to the degree guiding you. Long division will set it up and do 1 of each, and then from there, if I gave you homework, it'd be to do the next guy in line. Whoa, a 6, you can't even do that one at home. 4, can't even do that one. Alright, so we're doing the 2 easy ones. Alright, down here, how do you write a synthetic division? First, you can't use the factor. Factor means it's in a parenthesis. You have to use a 0. How do you get the 0? It's the number like right below it. Same number opposite sign, you may remember that. So on the outside of the door, I put that, I'm going to make this long L. It was going in at the top of this long L. The coefficients of each term, there's going to be a 1, there's going to be a 3, and a negative 3. This is how you set up. Oh, I hope they don't feel like that extra 3 is part of it. Well, they're here. Here. Do the long, hard one. Do the short, easy one so they know why they want to be able to do synthetic division. I can't help but feel that that's going to create a problem, so I mean, all right. Who knows what that means? Long one. Hey, Thomas, how do you do long division? Well, I find a number that I can put under here. I say, how many times does x go into that? When I get that number, I put it on the top, and I say, oh, it goes in there 4 times. Don't write 4, I'm just making that up. 4 times x is, and then I put it under here and I subtract. In other words, regular old division used to look something like this. Let's make it 4 goes into, let's say, 1, 13, 4. To divide, you say 7 times 4 goes to 13. It goes into 3 times. 3 times 4 is a 12, and you subtract. You get a number down, you do it all over again. How many times is 4 going to 14? And let's see, 4 times 7, no, 4 times 2, 3, 4 times 3, you multiply it. You kind of keep going down, you wind up with a remainder. That's regular division. Well, we're about to do it now, but ugly. Let's see if I can do ugly, fast, and then I'll go. Regular division. Not how many times does x go into this, but what do I need to do to this x to make it look just like this 2x squared? What do I need to multiply, rather, times this x to make it look like a 2x squared? Well, one, to get an x squared, I know I need to multiply an x. X times x is x squared. That part's cool. How do I get the 2? Well, if I were to multiply a 2 times them, I would have 2x squared. I don't know what to say. So here's what happens next. You actually do multiply times both of the outside pieces. So here's what it looks like. 2x times x is a 2x squared. Anybody know what 2x times negative 2 is? Say it again. Oh no, I see what you're thinking. I'm going to rewrite it so you can see the old-fashioned way that you used to have seen it before. A long time ago, if someone said, please distribute the 2x.
It would be 4x. Negative.
-4x. You would normally do the first 2. And the 2 times the 2. That's what you would normally do. I just wrote it up there because I was not late. All right, in any case. Take a look at that line. This line right here. Let's see if you're okay with where it came from. Then, like regular division, you would subtract this line with the subtraction sign. Here's what will happen every single time. The first 2 will cancel out. That's the point of it. You want them to be exactly the same. This minus itself is 0. You don't write the 0. And then the next line you do -7 minus a 4. -7 minus a -4. All right. Negative goes to double positive. A -7 plus a 4 is a -3. -3 for the x's. And his friend comes down. I'm going to pause there and let you look at it. Take a look at it, see what it does. Right now you're just writing down so you have an example in your notes. I'm going to do this other example here. And then that'll be that. Let's get you out of here. I want to see how many of these they put on the test to see, do they need to super know it or sort of know it. Hey, how do you do synthetic division? It's the same. It works on the same types of problems, but no thinking. Here are the steps. Step 1, bring down the first number on the inside to the bottom. That's sweet. That's nice and easy. Step 2, multiply and move up. That is 3, the outside number, 3 times that is 3. And you move it right there. That's sweet. What happens next? You always add 2 numbers that are in the same column. So multiply, bing, so down and up. But to come straight down, you add 3 plus 3 is a 6. Look at that 6. See if you're confused where it came from. The good news, we do it again. The 3 times the 6, bing, down and up. 3 times 6 is an 18. And we always add straight down. Negative 3 plus 19 happens to be a 15. The question is, okay, so what's the answer? What did we get? You start from going from right to left. You start by circling the first number and putting an R. That's your remainder, just like this was our remainder. The next number in line, he gets to be a regular number. This is what's going to go at the top. This is going to be the same thing. The next number, he gets no letter. The next number over gets an X. Let's see if they can feel that. R, nothing, X. If we went over 1, he would be X to the second power. We went over X to the third power. What is the final answer here? What is the number that would appear on top if we did this the long way? It would be X plus 6 plus 15 all over the original X minus 3. I'm going to have you pause, look at